In this video, we'll look at proving trigonometric identities. So once we begin with the fundamental identities, we can get to many other places from those. Of course, it's easy to decide when something is not an identity because all we have to do is try a test value and see if the left-hand side equals the right-hand side. For example, if we had sine x plus cosine x equals 1, all we would need to do to see that that's not an identity is just to plug in pi over 4 in for x. Of course, we would end up with root 2 over 2 plus root 2 over 2, which just gives us root 2, and that doesn't equal 1. So that's always a good place to start, is this actually an identity? So in this video, we'll quickly review the trigonometric identities. We'll talk through some guidelines for proving whether or not a particular expression is a trigonometric identity. And then we'll do an example. So first, here are all of the fundamental trigonometric identities again, so just to refresh your memory on these. And now let's look at the guidelines. It's always, always, always a good idea to start with one side of an expression. If you manipulate both sides of a given equation and end up in the same place, that's not really showing that one side of the trigonometric expression is equivalent to the other side. You have to start with just one, manipulate that side, and work your way to be equivalent to the other side. Of course, you can manipulate both sides and then restructure so you're starting with one side and then ending with the other, but it's important to start with one and work your way to the other. Always good to use your known identities. And a useful technique too is to convert to sine and cosine, because that makes it a little bit easier to see what's happening. So first, let's prove that cosine theta times secant theta minus cosine theta equals sine squared theta. Let's do this one by rewriting this expression in terms of sine and cosine. So we'll say, like, left-hand side equals cosine theta times secant theta minus cosine theta. So, like I said, we're starting with the left-hand side. We're going to try to work our way to the right-hand side. So secant theta, we know that secant theta is just 1 over cosine theta. And then we have minus cosine theta. If we distribute the cosine theta that's outside the parentheses, we end up with 1 minus cosine squared theta. And then by our Pythagorean identities, we have sine squared theta, and that equals our right-hand side. This is just one of many techniques that we have. A couple others that you will encounter. Combined fractions. If you have an expression that's like 1 over 1 minus sine x minus 1 over 1 plus sine x, you can combine those two fractions using kind of our algebra techniques. We can multiply both sides by something. We can multiply one of our sides by something clever in terms of 1, kind of like what we do when we're trying to combine two terms, when one is in a fraction and the other is not. We can simplify each side separately and then combine the two to make sure that we end up in the same place. And of course, we can use trig substitution. I won't talk about all of these techniques at length in this video. The point is just to begin to get you thinking about what kinds of techniques you may consider using when trying to prove whether or not something is a trigonometric identity. In the future, we'll look more extensively at these techniques. In class will be a good time. But for now, just focus on trying to follow your nose. Trusting your intuition is always good. And just remember that you don't have to start with the left-hand side. You can also start with the right-hand side of a particular trigonometric identity.